I'm creating this video because I'm not gonna be at school, but still I don't want you to miss the instruction. You have to pay attention to the information that I'm gonna give in this video. And the questions, they're not gonna be directly related to the information that I'm giving you, because you already know how to find independent and dependent variables. So the purpose of this video is just to show you what are the steps that you have to follow to identify the substance, and then from that point of view you have to design your own experiment. In this slide I'm putting the definition of an algorithm because that's what you're going to use in order to decide what are the properties that you're going to use to identify the solid that you have in the waiting board. An algorithm is a set of steps that you follow, and a step by step that are going to be created using different questions. You already know that you have a crystalline solid because that was the first question that you asked yourself. When I look at this substance, okay, do I have a crystalline or do I have an amorphous solid? You know that one example of an amorphous solid is butter. So butter is gonna melt at room temperature. Does that happen to the solid that you have in the waiting board? The answer was no. And in addition, you observe that solid that you have in the waiting board, they have like a crystalline structure. So you decide right away, when we were talking about type of solid, you decide that the solid that you have in there was not amorphous, it was a crystalline one. See over here that I put a low melting point, but over here I didn't put high, because that depends. Now, the difference between amorphous and crystalline is that the crystalline, they don't melt at room temperature. But within the crystalline, we have 4 different categories. We have the ionic one, which are ionic compounds, and you learn in physical science that ionic compounds, they are made of metals and non-metals. And also you learn about different ions when you were taking biology. We have the molecular ones. Molecular crystalline solid are covalent compounds like sugar. Glucose is an example of a molecular crystalline solid. You learn about that when you were taking biology and physical science as well. Metallic crystalline solid are mainly transition metals. Why transition metals? Because they're not very reactive. The other ones, the alkaline and the alkaline earth metals, you are not going to be able to see them in the natural stage, because they're very reactive with the oxygen that you have in the air. So metallic, usually, pieces of transition metals. And then you have covalent network. On the next slide, then we're gonna go over the 4 physical properties that you were searching for using artificial intelligence just to design the next step of the algorithm. Let me clarify something here on this slide because I don't want you to get confused. I know that what you were using to identify amorphous from crystalline was the melting point at the room temperature. But remember that plastics that are elastic, they are amorphous solids, and they are not going to melt at room temperature. What is the difference between butter, that is a solid melting at room temperature, and a plastic that is elastic? The arrangement of the particles. Now, what is the characteristic that you're going to observe in a solid that is elastic? That elasticity. That elasticity is going to tell you that you don't have a crystalline solid. In that case, it's not going to be the melting point. In that case, it's going to be, elasticity of the substance. Just to clarify that part, because we are using melting point in this case, but another way just to identify amorphous from crystalline is using, that elasticity. Okay, they can change, like you can bend that, you can fold that. Still, they are solids and they are so elastic because of the arrangement of the particles that is not following a pattern in there. Once that you decide that you have a crystalline solid, then you're going to start using the physical properties just to start identifying the substance. Okay, and I start over here with the melting point. because the melting point is one of the easiest properties that you can measure in the chemistry lab. And then you're gonna ask yourself, okay, the substance they have a high melting point, and you're gonna look at your table. When you look at your table, you know that molecular crystalline solid, they have a low melting point. And one example is sugar. You put sugar on your stuff and it's gonna melt. Okay? When you make a caramel. Now, if you are testing melting point and you realize that the substance is not melting at a low temperature, then you may have an ionic, a metallic, crystalline solid, or you can have a covalent network. Okay, so but you know for sure that it has a high, you know for sure that if the substance has a high melting point, you don't have a molecular one. And then you go to the next step. Remember that we are designing an algorithm. Crystalline or amorphous is crystalline because it's not melting at room temperature. Now we are going to use another instrument. We're going to input heat into the system, and if it has a low melting point, meaning that you are inputting energy and it's melting at a very low, relative low temperature, you have a molecular one. But if that doesn't happen, then you have three possibilities. And then you're gonna jump to the next physical property, solubility in water. Is that substance or is that thing that I have over there soluble in water? You're gonna get water, you know, you learned that in biology, that water is a polar molecular compound. So, meaning that you already know that it's not molecular, so you don't have to worry about polarity because you were using melting point first. Now that you're using water, solubility in water, if that substance or if that solid that you have in there doesn't dissolve in water, then it could be a covalent network or a metallic one. Okay, it could be. But if it dissolves in water, probably it's gonna be an ionic one because we have some ionic compounds that they're not gonna be soluble in water. And that's why you have to jump to the next physical property, which is electrical conductivity. Electrical conductivity, now you have to look at your table, because if you have a covalent network or a metallic one, okay, if you use electrical conductivity, you're gonna be able to decide. Metallics, they conduct the electricity very well, okay, very well. Covalent networks, they're used as insulators, like as electrical insulators, because they don't conduct the electricity. Now, let's say that you have an ionic one because you went through all these steps, and then you know that you have an ionic one. Ionic, when you dissolve them in water, they're gonna conduct the electricity very well. So once that you have dissolved in water, you can use a conductimeter to see if that solution is conducting the electricity. If that solution is conducting the electricity, then you can say that you have an ionic compound. The next, physical property that we discussed was density. Then you will use density just to see. You will find the density, and then I'm gonna show you later how to find the density of any solid, liquid, or gas. Okay, then you will find the density. When you find the density, then you can use tables just to realize what is the substance that you have in that weighting box. You already know. See, simple steps. You have an algorithm just to identify your solid. It's amorphous crystalline. It's crystalline because I see crystal. It's crystalline because it's not melting at room temperature. Now, does this crystalline solid has a high melting point? If the answer is yes, you have three probabilities or three possibilities. If the answer is no, then you know that you have a molecular one. That molecular one, if you have a molecular one, then you can go through the other tests you want to, because if you have a molecular polar compound or a molecular polar crystalline solid, that molecular polar is going to dissolve in water. But when you are going to the electrical conductivity, it's not going to conduct the electricity, and then you can use that to validate your inference. And then The final step is just to find the density, to look at the table to see what is the molecular solid that you have in there. That is the idea. With that idea in mind, then you're going to start designing your experiment. And see that in this example or in this video, I'm only addressing physical property. So I want you to think, what is the variable that I'm changing here on purpose? Am I changing the substance? What is the thing that I'm changing? So that's what you have to think, that you have, now that you have the independent variable, what is the thing that you are observing? What is the observable variable? With that information, okay, can you write your hypothesis? What would be a good hypothesis for this experiment? Now that you have identified independent and the dependent variable, okay, what is a good hypothesis for this experiment? Remember that you can have more than one and all of them, they can be right. In addition to that, when you're designing your experiment, you need to find a control group. Would you like to use a control group? Let's say that you already know, like a solid that is molecular. You can use a solid that is ionic, or you can even use a solid that is metallic as you control. And then you're going to compare with the results that you're getting. See that? Is that possible? What would be, your control group? You can have more than one answer in there. Because remember that the control group is the one that is not going to be affected by the independent variable. Meaning that you already know what's gonna happen. Okay? For that specific solid. So what would be a good control group for this experiment? And what are the things that you're gonna keep the same? So what are the constant? At least three. You need at least three constant. At least three constant for this experiment. What are 3 things that you're gonna keep the same? Now that you have the independent, that you have the dependent, that you have, information about what can happen, so you can make an inference in your hypothesis. Now that you know how to find a control group and all the factors that you need to keep the same throughout the experiment, how are you going to design an experiment? Can you use artificial intelligence? And the answer is yes. But that's the next lesson. I'm going to show you how to use artificial intelligence knowing all of this.